Hello, friends. Part 3 of your podcast on Chapter P in the AP Stats book. We're right here. Explain the difference between survey and experiment. I already mentioned this. Any experiment will have a control, and basically that means you're going to make at least two different groups. One group is going to get some treatment. So one group is going to get a headache medicine, and the other group is going to get a placebo, a fake pill that looks like the headache medicine. And we're going to compare and see, did one group get rid of their headache quicker or more effectively than the other one. And we do this because of what's called placebo effect. Some people, if you give them even a fake treatment and tell them it's going to make their headache better, they're going to think their headache got better. So we want to compare how much better did the treatment actually do than even people that think that they got some treatment that was going to fix whatever. So we can also have different dosages, so we could have multiple groups, but a control just means I got something to compare the treatment to. Survey we already mentioned, that's asking questions. Already mentioned all this about the difference between face-to-face, written, and over the phone. So you have to take things like that into consideration. Um, that's that. Again, a survey can't be used to establish cause and effect. All right. How an experiment differs from an observational study. Observational study, I already mentioned, that's when you just watch some situation. You can watch how animals behave. You can watch how the paint finish comes out on refrigerators from an assembly line. You can watch any number of things, but you're just watching. So there is no control. You can't compare it to anything, but you can look for patterns that may support uh, some conclusion or other. And I already mentioned this. This is important because a lot of people want to cause and effect. If I wear a seatbelt, I'm less likely to be killed or seriously injured in a car accident. If I wear a helmet when I ride a motorcycle or a bicycle, I'm less likely to be killed or have a serious injury doing those things. So we're looking for cause and effect, and the only way I can really do that is through experiments. But again, experiments can't always be performed if you're looking for response time. If an animal runs out in the road when you're driving a car, you can't simulate the surprise because if you're sitting in a simulator, you know you're going to have to brake for something. You're prepared for it. Whereas in the car, you might be changing the radio station or talking on a cell phone or drinking a cup of coffee and be distracted. So there's no way to simulate that reality in an experiment. So experiments, even though they're more useful, have their limitations as well. All right, the difference between individuals and variables. If I want to know how well two different fish foods work, the individuals that I'm going to measure are going to be the fish, and the variables are going to be how much fish food is given and the weight of the fish. So I have an ability to compare. If I want to know how a machine's working that makes ball bearings, then the individuals that are measured are the ball bearings, and the variables would be the different measurements or how many of them are made over a certain period of time. All right, so I have these individuals, which are the things that I'm measuring, and the variables, which are sort of the things that I want to know about. Uh, so what we're doing in the big picture when we get to inference is, and even starting from data analysis, is I want to be asking this set of questions about any data that I work with. Who are the individuals? What are the variables I'm measuring of those individuals, which again could be people or animals or things? Why was the data gathered? In other words, here I'm looking for bias. I mean, what biases could be present just in how the data was collected? When, where, how, and by whom were the data produced? Is this old data? Is this before 9/11? Is it before penicillin was invented? Is it, when did this happen? Where, how, and by whom? Because all this affects, when you make conclusions about a set of data, you can't really generalize it outside of the population that it was gathered from. So it's real important to know. We'll continue in the next podcast.